The next property is about conversions. It is, if you have something like sine inverse of x, and if you want to convert this into cos inverse of something. So sine inverse of x is equal to cos inverse of what? Or if you want to convert sine inverse into tan inverse. So sine inverse of something is equal to tan inverse of what? Similarly, secant inverse of what? Cosecant inverse of what? Cot inverse of what? So this is what we are trying to understand. So first, easy conversions happen when x is positive. So first let us do the straightforward derivations. So if x is positive, that is x is in between 0 and 1. So if you take sine inverse of x, so let us assume that this is cos inverse of some y. So let us see what y is. So let us try to understand what y is. So sine inverse of x is equal to cos inverse of y. So let us assume sine inverse of x is equal to alpha. Let us say cos inverse of y is equal to beta. So because x is positive, sine inverse x lies in the first quadrant. So cos inverse y also has to lie in the first quadrant. So y has to be also positive. So if sine inverse x is equal to alpha, then x is equal to sine alpha, and cos inverse y is equal to beta implies y is equal to cos beta. So x is equal to sine alpha, y is equal to cos beta. You need to find what y is in terms of x. Now since alpha is equal to beta, cos beta can be written as cos alpha, or cos alpha can be written as root of 1 minus sine square alpha, and sine alpha is x, that is root of 1 minus x square. So y is equal to root of 1 minus x square. That means sine inverse x can be written as cos inverse of root of 1 minus x square. Similarly, you can convert sine inverse into tan inverse using appropriate identities. But what we shall do is, in the exam, you cannot directly do this derivations, it is time taking. So let us try to understand the shortcut by which you can go from one inverse trigonometric ratio to another inverse trigonometric ratio. The shortcut process that we use for conversions is called the triangle method. Triangle method. This is very similar to the triangle method which you apply in the chapter of trigonometry to find the other trigonometric ratios if one trigonometric ratio is given. If sin theta is equal to 1 by 3, find the other trigonometric ratios. This is a very standard question which we deal in trigonometry. So let us just revise what we have done. So if sin theta is equal to 1 by 3, find other trigonometric ratios. If this is the question. So how did we do this? We draw triangle, the 90 degrees here, and we mark this as theta. So I am doing this with the help of triangle method. So sin theta is 1 by 3, so we write the opposite side as 1 and the hypotenuse as 3. Because sin theta is opposite side by hypotenuse. So sin theta is 1 by 3. So from these two numbers, using Pythagoras theorem, you can find what this length is. So this length is root of 3 square minus 1 square. It is root 8. So this can be written as 2 root 2. So this has been found using Pythagoras theorem. So whenever a ratio is given, two sides can be written and the third side can be found out from Pythagoras theorem. Now sin theta is given as 1 by 3. So cos theta numerically has to be equal to adjacent side by hypotenuse. That is 2 root 2 by 3. Tan theta is opposite side by adjacent side. 1 by 2 root 2. So this is how you find the trigonometric ratios using triangle method. If you want cot theta, you go adjacent side by opposite side, 2 root 2 by 1. If you want secant theta, 3 by 2 root 2. If you want cosecant theta, 3 by 1. This is the triangle method, which helps you in finding the remaining trigonometric ratios if one of them is given. Now the same triangle method will be useful in conversions from one inverse trigonometric function to another inverse trigonometric function. Now, so let us say we need to convert sin inverse x into other trigonometric ratios. So let sin inverse x is equal to theta. That means sin theta has to be equal to x. If sin inverse x is equal to theta, sin theta has to be equal to x. So if you draw a triangle, a right angle triangle with theta here, so sin theta has to be equal to x. That means the opposite side is equal to x and the hypotenuse has to be equal to 1. Such that opposite side by hypotenuse is x. Now once you know these two sides, can you find the remaining side using Pythagoras theorem? Yes. This will be root of 1 minus x square. Now, this theta, which is sin inverse x, what is it also equal to? So, sin inverse of opposite side by hypotenuse will be equal to cos inverse of adjacent side by hypotenuse. So, sin inverse of x is equal to cos inverse of root of 1 minus x square. This is equal to tan inverse of opposite by adjacent, x by root of 1 minus x square. And if you want to convert into others, secant inverse of hypotenuse by adjacent side, 1 by root of 1 minus x square is equal to cosecant inverse of hypotenuse by adjacent by opposite side, 1 by x, is equal to cot inverse of adjacent side by hypotenuse, root of 1 minus x square by x. So this is how you convert one inverse trigonometric ratio into others. So you can have a lot of different conversions. So you just need to use the triangle method and get the answers. So remember, these conversions will be exactly valid only for positive numbers, because when x is positive, all these numbers are positive and all of them lie in the first quadrant. So let us also see what happens if x is negative with some examples.